Okay, I'm going to pick up where I left in this other problem. And the purpose of this particular exercise will be to figure out what my sample size should be. So let's say that I conduct a preliminary study with 150. Okay. Now, the preliminary study came up with a p-hat value of 30%, an estimate. My standard error is that 0.036. But in order for this to be worth your while, you need to get it down to 1%. The standard error here needs to be 1%. So what do you do? Okay, we're going to use a particular formula to answer this. And this formula is as follows. So here are my formulas. This is the one I'm going to be using. Um, in your book, it would look like this, but it actually doesn't appear in your book at all. Where is this formula coming from? It's coming from this one right here. Uh, margin of error is equal to z star times the square root of p hat times q hat divided by n, where again 1 minus p is the q. Now, what's the deal with the stars? Well, let me just kind of explain that a little bit here. Your book does use q star and sorry, q hat and p hat, but what the little star emphasizes is that these are just guesses. It doesn't come from data necessarily, or it may come from a preliminary study. So I guess in a sense is data, but really what I'm trying to emphasize with little stars is that these are just little guesses. These are user defined. So a little star is just going to be user defined. However you want to define it, it's up to the user. It could come from preliminary data, it could come from a guess, or it could come from the worst case scenario, which is making p equal to 0.5. Means the worst case scenario is 0.5 has the most variability. So a coin toss, if it's truly 50-50, that's a scenario where you have the most variability. Anything towards 0 or 1, the variability starts to go down as you approach. And since we're trying to figure out sample size, the worst case scenario is when you have a lot of variability. In other words, to cut down a lot of variability, you're going to need even a larger sample size. So I could use one of these formulas right here. And that's what I'm about to do. So what I want is this. I want, as a matter of fact, I'm going to make it even more stringent. Margin of error to be 1%. That's pretty tight. I want to know the true proportion to within 1%. So using that formula, and let's say that I want 99% certainty. I want to make sure that my true proportion is in the interval I create. So now I'm ready to calculate. .576, my margin of error goes to the bottom, 0.01. Square everything. And now, because I'm the user, I will use this preliminary study. So in fact, let's see, I'll use this one, because that was the first one I used. So I'm going to guess 0.31. So let me just choose 0.31. Times 1 minus 0.31. So again, this is what I'm calling P star. Your book just calls it P hat, Q hat. What is it? It's a guess. It's a guess of what the true value might be. Now hit equal to. And it says, boy, if you want to be that certain, which is 99% certain, and you want to be down to 1%, you're going to need a sample size of 14,193. 0.92, obviously you cannot get a sample size of that, so really the sample size becomes 14,194. So if you want to be that certain, which that much accuracy, that's the sample size you're going to need to be within 1%. So I'm going to do it. I'm going to select my random number generator. Random seed. Change it again. Number of random numbers. This time I'm going to need 14,194 of them. And where to dump this? I'm going to dump it right here. Okay, here we go. All right, there's my 14,194 problems. I'm going to cut to the chase and just calculate p hat. Well, okay, that might be off a little bit here. All right, so take the average, and I have an average of 0.252. Okay, so that's my new p hat value. Oops. Now, what's my confidence interval? The reality is I might be off a little bit, but because I need to use this as my new standard error. But technically speaking, the way I set it up, it should be this. Well, very close to it, because again, the margin of error, I used the standard error was a calculation approximation, but really what it should be for all practical purposes is this. That's one. That's the other one. In other words, I engineered it so it would be 1%. Now I can't quite get 1%. I should be even better than 1%. So to get the actual interval, here's a lower end. And here's the higher end. And you can see that it's actually much better. Actually, it's pretty close. 0.242, yeah, that's very close. But anyway, now I am 99% certain that the true proportion of this population most likely is in this interval. Well, it's in this interval that I've created. Do I know where? No, I don't know where. How close is it to the ends? I don't know. But I'm 99% certain that I've actually